this video, we will discuss Bronsted Lowery concept of acids and bases. In 1923, Bronsted and Lowery proposed another theory to overcome the shortcomings of Arrhenius theory. This theory is known as Bronsted Lowery concept of acid and bases or Bronsted Lowery theory. Now we will see what is Bronsted Lowery theory for acids and bases. An acid is proton donor and a base is proton acceptor. An acid is proton donor and a base is proton acceptor. Usually H plus sign is known as proton. We will understand Bronsted Lowery theory for acid and bases with the help of some examples. We will take the first example. This is the reaction between HCl and water. We write the reaction between HCl and water. HCl and water. This is water, H2O. Water has bent or angular structure. Now here in this reaction, HCl is Bronsted acid. HCl is Bronsted acid. Why? Since HCl is proton donor. So that's why HCl is acid, Bronsted acid. While water is proton acceptor. Water is proton acceptor. That's why water is Bronsted base, or simply we can say it is a base. Now after accepting proton from HCl, water changes to here one electron is left. Since oxygen has given whole pair of electron for the formation of covalent bond with hydrogen, coordinate covalent bond with hydrogen, right students? So that's why there is a plus charge on oxygen, or we can say overall on a molecule we have a plus charge. Plus after donating proton, HCl changes to chloride. This species which is formed H3O plus, this species is known as hydronium. This is hydronium. Hydronium students, simply it is written as H3O plus. This is hydronium. To understand the concept in a better way, we will see one more example. We will write the reaction of ammonia with water. We will write the reaction of ammonia with water and we will see which is Bronsted acid and which is Bronsted base. Ammonia, NH3. This is the lone pair of electron which is present in the valence shell of nitrogen. When ammonia reacts with water, water have bent or angular structure, H2O. Now students, we will see what reaction occurs. In this reaction, water is proton donor. Water is proton donor while ammonia is proton acceptor. डायरेक्शन ऑफ एरो इज फ्रॉम डोनर टू एक्सेप्टर. डोनर टू एक्सेप्टर, हम एरो की डायरेक्शन डोनर से एक्सेप्टर की तरफ बनाएंगे. आफ्टर एक्सेप्टिंग प्रोटॉन, अमोनिया चेंजेस टू NH4 प्लस. नाइट्रोजन हैज गिवन होल पेयर ऑफ इलेक्ट्रॉन फॉर मेकिंग ऑफ कोवलेंट बॉन्ड with hydrogen, so there is a plus charge on nitrogen. And after donating proton to ammonia, water changes to hydroxide ion. This is known as ammonium ion students. If we write the structure of ammonium ion, Structure of ammonium ion would be like this: NH4 plus. This is the structure of ammonium ion. NH4 plus. This is ammonium ion. Ammonium ion, as well as we get hydroxide ion. I hope concept of Lowery Bronsted acid and bases is clear to you. Here we are asked to identify Bronsted acids and Bronsted bases in the following reactions. Some reactions are given and we are asked to identify Bronsted acids and Bronsted bases. So let's start. We will write the first reaction which is given. The first reaction is reaction of sulfuric acid H2SO4 H2SO4 with water. H2SO4 on reaction with water, it will form HSO4 minus. This is known as hydrogen sulfate ion or bisulfate ion plus H3O. We are asked to identify Bronsted acid and Bronsted base in this reaction. Now we will know what are Bronsted acids. Bronsted acids are proton donor, while Bronsted bases, they are proton acceptor. Here we can notice H2SO4. H2SO4 is proton donor, right? And water is proton acceptor, because after accepting proton, water changes to H3O. H2O changes to H3O. It means one proton is added in H2O, that's why it is changes to H3O. Since water is proton acceptor, so that's why it is Bronsted base. Bronsted base. Clear? Now H2SO4 is proton donor. Since after donating proton, H2SO4 changes to HSO4. H2SO4 changes to HSO4, that is hydrogen sulfate ion or bisulfate ion. Here we have one hydrogen atom because it has donated, H2SO4 has donated its one of the hydrogen atom to water. Since it is proton donor, so that's why it is Bronsted acid. So H2SO4 is Bronsted acid. I hope this is clear. Now we will see the next question, next example which is given. In the next example, we have given another reaction, number 2, CH3COOH, CH3COOH, acetic acid on reaction with water in a reversible reaction. In a reversible reaction, we get CH3 C double bond O acetate ion plus H3O, that is hydronium ion. Now we will identify which is proton donor and which is proton acceptor. Here we can notice H2O. H2O changes to H3O. After accepting one proton, H2O changes to H3O. Since H2O is proton acceptor, that's why it is Bronsted base. As we know, Bronsted base, what are Bronsted bases? Proton acceptors are Bronsted bases. After accepting one proton from acetic acid, H2O changes to H3O. H3O is known as hydronium ion. Now CH3COOH. CH3COOH changes to CH3COO. After donating proton, CH3COOH changes to CH3COO. CH3COOH is acetic acid, while CH3COO is acetate ion. So here in this reaction, acetic acid is Bronsted acid since it is proton donor. It is proton donor, that's why it is Bronsted acid. While water is proton acceptor, that's why it is Bronsted base. I hope this is clear. Now we will see the next question which is given. In the next question, here we have in the number 3, here we have reaction of H2S hydrogen sulfide with ammonia NH3. In a reversible reaction, after the reaction we get NH4 plus HS minus. Now here we are asked to identify which is Bronsted acid and which is Bronsted base. Here we can notice ammonia changes to NH4. NH3 changes to NH4 after accepting one proton from H2S. Since ammonia is proton acceptor, that's why it is Bronsted base. इसमें एक प्रोटॉन ऐड हो गया, NH3 changes to NH4 after accepting one proton from H2S. That's why ammonia is Bronsted base. Now see H2S changes to HSO4 minus after donating one proton to ammonia. Since H2S is proton donor, it is proton donor, that's why it is Bronsted acid. It is Bronsted acid. I hope this is clear, students. Now we will see one more question which is given. In the next question, we are given reaction of water H2O with ammonia NH3. In a reversible reaction, we will get NH4 plus OH minus. We are asked to identify which is Bronsted acid and which is Bronsted base. Here we can notice ammonia changes to NH4, NH3 changes to NH4 after accepting one proton from water. Since ammonia is proton acceptor, that's why it is Bronsted base. As we know, Bronsted bases are proton acceptor. Now here H2O, that is water. Water, after donating one proton to ammonia, water changes to hydroxide. Since water is proton donor, so that's why it is Bronsted acid. So in this reaction, water is Bronsted acid while ammonia is Bronsted base. Now we will see what next question is given. In the next question, we are given a reaction of, this is question number 5, reaction of HCl with water. In a reversible reaction, HCl on reaction with water will form hydronium ion plus chloride ion. We are asked to identify which is Bronsted acid and which is Bronsted base. In this reaction, students, here we can notice H2O changes to H3O after accepting one proton from HCl. Since H2O is proton acceptor, so that's why it is Bronsted base. Bronsted base. HCl changes to Cl minus. HCl changes to chloride ion after donating one proton to H2O. Since HCl is proton donor, so that's why HCl is Bronsted acid. So in this reaction, HCl is proton donor, that's why it is Bronsted acid. Water is proton acceptor, so that's why it is Bronsted base. Student, I hope you will understand the concept of Bronsted acid and bases. In this session, we will discuss limitations of Bronsted Lowery concept. That is, what are the defects of Bronsted Lowery concept? Bronsted Lowery concept is also not so comprehensive because by following this concept, certain compounds cannot be considered as acids or bases. Although They act as acids or bases. For example, sulfur trioxide is an acid. Sulfur trioxide, it is an acid. But it cannot donate a proton. It is not proton donor, but still it is an acid. Similarly, calcium oxide, that is CaO. Calcium oxide is a base. It is a base. But it cannot accept a proton. Calcium oxide is not proton acceptor, right? But still it is a base. So these are the limitations of Bronsted and Lowery concept. I hope these are clear to you.